Hey guys, welcome to another video about space, physics, and all that. I think I'm gonna name that playlist that space, physics, and all that, where I'm gonna be making this like podcast-esque series, um, talking about these kinds of things. And today I want to be talking about time, one of the most complex, if not the most complex, topics of all of physics and science. So how we view time, whether it's in fiction or whether it's real, generally we like to view it as a linear form. So at one point, this is kind of what we'll view time as, right? There's a beginning and it goes on to no end. We view it as this sort of form because of how things are portrayed. And one of the things I'd like to talk about and kind of explain is the grandfather paradox. So, the grandfather paradox, let me explain that. Sorry for my terrible handwriting, but I promise it's better. Um, so, the grandfather paradox is a time travel paradox. So, a lot of people like to talk about time travel and the potential of time traveling in the future. Well, a lot of things in physics tend to not really like unless like time traveling into the future, there's nothing really proving that we could time travel into the past, and this is kind of where I'm going to be talking about in this episode. So in the grandfather paradox, right, you could take literally any course of event, right? You are in this point of time, right? So this is you, um in actually, you know what, I'll make you at the arrow, right, just to keep it at the present. So this is 2026, right? This is you. Say you want to go back in time to change something, right? Say you want to go back to like this era, right? Well, say this is like 1940. You want to go back and kill Hitler, right? So you go back in time to end Hitler before his like whole reign and before all like the evil things he does. And if I am wrong about the fact that he did evil things before after this time, I do apologize. I am not a history person, so if this is the wrong timeline, but I'm just going to use an example, right? You want to kill Hitler, so now the you that went back in time to kill Hitler won't exist, right? Because you in this time hates Hitler, right? You hate Hitler. You don't like him. You just hate him. Okay, and now you somehow break the laws of physics and you travel back in time to when Hitler was alive, and then you kill Hitler. Okay, and this is assuming I'm just gonna remove this, right? I'm gonna say before he was born, right? Right. So like you somehow you end the mother or something, like you find some way to end the mother, like not like have the mom not have the baby and change the past. Now the you from here won't exist because now the Hitler you remember doesn't exist anymore. The hatred that you have won't exist because Hitler won't exist. Hitler won't be there for you to have a reason to go back in time. So this can't happen because you won't exist. You won't have the reason, right? Another way I could explain it is like say you go back in time to say have your parents meet at an earlier date, right? Let's say here is when your parents meet. This is like your whole life, right? This is a bad. I'm gonna draw that again. Say this is when your this is like the timeline of when your parents met, you were born here, and this is the present, right? You go back in time before your parents meet. I'm going to try to draw that before your parents meet to have them meet a little bit earlier than they met. Now, because they met early, you would be born at a different time, have different experiences, have a different childhood, different friends, and you here won't exist, right? And the reason why this is very confusing to understand is because of how confusing time is, and also because I am kind of a bad person to explain this with. But like I'm trying to say is that the you that wants to go back in time won't exist because it'll be replaced by this. But then because you won't exist, you won't go back in time to have your parents meet, and this just won't work at all because of the fact that you won't exist. And I'm repeating a lot because this is a loophole type paradox, right? In both scenarios, the you that goes back in time will never exist because you will never have a reason to. In the Hitler scenario, right? You go back in time, have Hitler cease to exist. You won't know the Hitler that you knew, and that will prevent you from going back in time. So that's the grandfather paradox. That's basically one of the paradoxes of why time travel is not possible from not from like a sort of non-physics point of view. Like if we assume that time travel was possible to the past, it won't happen because the you or the person that goes back in time won't exist because the reason they travel back in time won't exist, and it's just like a constant paradoxical loop of like you go back in time, but then that won't happen, but then you won't go back in time, and then that won't happen. It's like a constant loop of time, right? And that's one of my favorite paradoxes I love to talk about and love to explain because of how complex and intricate this really is. So going into another theory of time, and this one's also one of my favorites. Not the favorite, but it's one of my favorites, and it's called presentism. And none of the theories I will talk about after the grandfather, none of this video is like by me. All these theories, all these paradoxes, all of these things I talk about in this video are all um have all existed before me, and if not before me, they've existed during me. But I never made any of these. I will not take credit for these. These are all theories I've done research for, I've looked up for, and I've done a little bit of studying for. And yeah, so a lot of the theories aren't my theories, but it's just theories I like to explain about, right? So one of the theories is presentism, right, or however you want to call it. Here's how you would spell it, right? Presentism, right? So what presentism is, right? So I'm going to bring back the linear scale of time, right? That's okay. We'll take that, right? So this is time, right? In presentism, it's that you only live in the present. Only that exists. So only this exists, right? These don't exist. When you as you go time, this just gets erased. Like time is just gone, right? It's only like that's it. There's no future, there's no there's no past, there's nothing because the only thing that exists is right now. And that's why it's not a very definite thing because again time is a very complex system and it's a very complex idea to acknowledge because it's nothing that we can touch, it's nothing that we can physically see time, it's something that goes on and on, right? The only way we can put like even view that the past exists is because of artifacts, and we can't even prove how those artifacts came to be. How can we prove the like at this point the Civil War happened, right? How can we prove that dinosaurs existed other than the fact like their fossils exist? How do we know like we can't go back in time to check the fact that, like dinosaurs existed. We just see fossils. We see proof of it, we do, but after that, like me talking, right? As I talk, everything I say in the past just goes gone, right? It's gone, and I can't bring that back. And the future doesn't exist is because we're constantly in the present, and that's why it's like hard to determine whether we can actively travel into the future or we can actively travel in the past because we don't know if they exist. We don't know if like if it's like one thing and if it's just one single present, right? And a theory that's the exact opposite is called eternalism, right? So eternalism is the exact opposite. Eternalism. Again, I do apologize for my terrible handwriting, right? So these two are opposites. So uh, opposites. So in the theory of eternalism, right, is that everything exists all at once. So with the same scale, right, I'll bring back this. That was the best line I've ever done. Wow. So this is right. This is time. In eternalism, it's that every single moment in time exists at the same time. So dinos, Civil War, right? 2026 and the future, right? So these all exist simultaneously. So all exist simultaneously. Or anyway, I'm not spelling that out. So at the same time, right? All these exist at the same time, simultaneously, right? The past exists, the future exists, and the present exists. And it's kind of like a DVD or a CD player or a movie. Like whenever you play a movie, you have like this like bar of like, you have like 0000, and then you have like 249. Oh, forgot the first zero. 249 and like 03, right? That's kind of what eternalism is. We like the past exists, right? Past, and we're just at like one frame or like at one point in the analogy of a movie, right? We're at just one part of the movie. We're at one scene, right? So this is the present, and this is the future, right? Same thing here. So all of it exists at the same time, but because of the laws of physics, we can't really go back in time to access all these information. We can't go like because of how physics works, how or at least physics relative to Earth. Sorry about that weird noise I just made. Um, like it's hard to explain because I'm not a physicist myself. I'm a computer science student. All these theories I'm talking about, all these analogies and everything is just from my general knowledge of things that I know about astronomy, astrophysics, and all these stuff. So it's hard to explain for me to explain, but I think it's also good that I'm explaining because I'm both a person that isn't an astrophysicist, but I'm also like into astrophysics and astronomy. So it kind of have like I'm like in the middle ground where I can explain it to other people. So yeah, this episode's gonna be a bit longer. Ironically because I am talking about time. But yeah, so um and we don't really know how we only view time relative to Earth, right? For example, light years, right? So light years basically is the distance it takes light. So light in the universe, light is universe's speed limit, right? So nothing can go faster than the speed of light without having infinite energy and infinite mass. Like um universe universe's speed limit, and I would love to go um, into the math of this um, and like speed limit, but that's not what this video is about. So light is the universe's speed limit, right? Um, and I'll go into light. I think in another episode, maybe the next episode, about light and traveling in space time and all that. But really, like light is the universe like speed limit, or also known as c. Why it's c? Don't ask me. I didn't make it up. You can Google that yourself. But okay, going back to what I was talking about, right? Say this circle is Earth, right? You know, boom, planet, yeah, continents, Earth, woohoo, right? This is Earth. So we view times, and this is like the orbit. I'll say this is the orbit. Okay, and there's a distance in space is it's called light years. So you say you're here, right? We'll assume this is 1 light year. I'll put L. Or actually, I'm not going to do that. So 1 light year, right? From this point to this point, this is 1 light year. Assuming this isn't a two scale, so I'm going to add that to not. Okay, I'm terrible at writing. So not to scale. We'll just assume this is 1 light year relative to the Earth, right? And the reason I'm saying relative to the Earth is because we view light year is just that's the speed it takes light to reach, right? So 1 light year takes light 1 year to reach Earth. And that's why time is so different across different galaxies. So when scientists say that, say this dot's Earth, right? And they say, oh, this is this many light years away, right? This here and this there, right? They say like, oh, this is like 70 million, like 70 million light years away. It literally means light from this planet takes 70 million years to reach that planet. And because we only see light in that time, we're seeing this in the past. So we're seeing this 70 million years ago. And that's how light works overall, right? You everything you see is just a delay because it takes time for light to reach your eyes. That's how anything works, right? You have, light, this is the sun, right? Light goes to something, then bounces off, and then goes, this is your eye, right? It goes into that. And it takes time. It was zero point 0.8 seconds. I think it's less than that. I think it's like 0.08 if I'm not wrong, like 0.08 or yeah, I think it's around 0.08. I might be wrong, but I know it has 8 in the name. So, that's how long it takes for light to reach your eye and for you to see it. I might be wrong about this, so you could fact check me and comment on how wrong or how right I am on that. So but overall, it still takes time for light to reach your eye. So everything that you see, everything like from your phone to your laptop to your friend to just a tree outside, you are viewing it as it was in the past, right? Sure, it might not be that far in the past, so you're not seeing too many changes, but if we're talking in the scale of the universe, we're seeing this star or this planet or this galaxy or this nebula 70 million years ago. In this analogy, we're viewing this 70 million years ago and we're viewing it in the past. We don't know what this looks like right now because it will take 70 million light years for us to see it. And to see it as it is in 2026, we're going to have to wait another 70 million like years. So this is like 70 million years ago, right? So we're going to have to wait another 70 million years, and this is how the star was, or this is how the planet looked in 2026. That's why it's such a mind boggle, right? Like, this is kind of a better view of what I'm trying to draw, right? This is Earth. This is 70 million, like, it takes 70 million years for light to reach our eyes, to reach not even our eyes. It takes 70 million light years to reach a super high tech camera, like a space company did somewhere in the world. And it's like, oh, this star exists, right? And we only see it, right? In Interstellar, one of my favorite Christopher Nolan movies of all time, right? We didn't even know what a black hole looked like. We didn't get a picture of a black hole until like years later after the movie released, right? Like, that's how crazy space is because of like space is so abnormally huge. It is so much to comprehend. I'm going to be talking about that in my next video about how absurdly big space is. And this is kind of like a topic about it, right? Like 70 million light years is only relative to the Earth, right? Going back into the time, 70 million light years is only relative to us, right? That's only relative to, one second. I'm gonna go back. That's us. That's only because of the fact we're talking about relativity to Earth's time. The reason um sorry about that. That one's um one sec. Sorry, that was a text from my friend, but and emails because why not while I'm making a video? But don't mind that. That's just because I'm filming on my iPad. So, anyways, as I wanted to say, right, time as or not time, light years only exists because we're taking into the factor of Earth years, right? If you look at the solar system, right, I'm going to draw it in the classic format that we've seen since like third grade. This isn't how the solar system is. I'm just going to draw it as it is, right? So sun, you know, Mercury, Venus, Earth, Mars. Um, I think it was I forgot the rest, but it's like the other planets, right? Right. These are the planets, and I'll just again, this is not how the solar system looks. This is just a visual representation. Okay, this is Earth. Okay, 1 year on Earth, I'm going to draw a terrible orbit of Earth. That's 1 Earth year, right? That's different from Mercury. That's different from Uranus. Yes, I know how that sounds. That's different from everything because Earth year is only relative to us. We know what Earth year is like. But if you talk about relative to like Saturn or relative to like Andromeda or relative to some other planet, it's going to be different because orbits are different. We orbit the sun at a specific speed, a specific distance, at a specific like spin, right? Not every single planet, no planet is like that. Mercury is completely different. 1 year on Mercury is like 88 days around Earth. 1 year around Neptune, I think is like I think how much. Let me look that up real quick. I have my laptop in front of me. So, how much Earth year is 1 Neptune year, right? It is 165 Earth years for 1 Neptune year, right? That's 60,000 days. See, so 1 Earth year, right? 1 Earth year is equal to is or not 1 Earth year. Sorry, not 1 Earth year. 1 Neptune year. Let me erase that as well. Why is this erasing? Sorry. That's. Let me just erase these from my eraser. Okay, sorry. So 1 Neptune year is equal to 165 Earth years. I'm gonna put EY, right? 165 Earth years. That's crazy, right? That's why time we only view it as like a fact as like relative to Earth, as relative to um like as relative. I cannot speak for some reason. I apologize for that. But we only view it relative to what we see as Earth. If we view time from Neptune or Uranus or Mars, is going to be different because of how time moves, right? Mars moves different. Venus moves different. Everything moves differently. So viewing time is only we're only viewing it as this specific unit or this specific number or the specific year or word is because of the fact that we're only viewing it relative to what Earth's is, right? Light year exists because only of Earth. So if we view something, let's say like this blob, right, is the Andromeda. Androm I'm pretty sure that's the closest galaxy. Andromeda galaxy, right? Earth, and I'll draw like the Milky Way. Terrible drawing of the Milky Way. That's not the Milky Way. Like that's the Milky Way. So I write better than this, guys. I do apologize again for my handwriting, right? And that's the Milky Way. So if we view something from a planet or a star or somewhere in the Andromeda galaxy, it's going to be different because time works differently in the Andromeda galaxy. That's the theory of relativity. and or not, yeah, that's like time relativity. And there's a whole equation for that. I actually will write that right now once I find it. I have it somewhere. Yeah. So gravitational time dilation, right? Or not gravitational time dilation overall, right? So this is one of Einstein's equations, right? So time equals t0 over the square root of 1 minus v squared over c squared, right? This is your time. Okay, that's light speed, and that's velocity, right? So say you're traveling at 99.9% speed of light, right? So that's 90 99.9% speed of light, right? And you travel from your perspective, so your time would be 1 year, right? This time would be roughly 22 years on Earth, right? This number would be different if it were on like Mars. Like Mars would be yada yada yada. You know, Neptune would be yada yada yada, right? So that's kind of why time is so trippy when it comes to um when it comes to time, like looking at it from a different perspective, is because of how like fast things are going, distance you're going, how long you're going, and a lot of things related to this. That's why it's such a complex topic, is because we know nothing about it, but we also know a lot about it, but we don't. And I'm not a physicist. I don't claim to be a physicist. You know, I'm taking the quote from Josh, but that's being chronically alive. But time isn't something like we can measure, because we're only measuring it from like relative to the earth, or like that's why it's going to be different. Like this 22 years is different on these on Mars and Neptune. It's why going at 99% of the speed of light for a year is only that is like a lot of time on earth. You can go a year for speed of light, and a dude could be born, be an adult, and literally be like literally be legal to drink by the time you only reach 1 year in 99.9% of the speed of light. That is how confusing time really is, and this is kind of just all of what I've explained in the thing in this video. So I don't even know how long this has been going on. So I will be posting this later today. Yeah, so just like time isn't something that's like one thing, because time isn't something that we can measure. We can measure a lot of things um physically, but time isn't something that's like one thing you can hold. You can't hold time itself, right? So it's it's not something I can easily explain, and not something a lot of scientists can explain either. And I'm not saying I'm as smart as a scientist, because the scientist definitely knows a lot more about time and a lot more about space than I do. But it's something that I don't think anyone can explain. So yeah, hopefully you guys watch to this part of the video. Like and subscribe if you guys want more of these. Um, Hopefully you guys do. If not, totally cool. I can't force you guys to do anything. I can't make you guys do anything. So yeah, thank you for watching. See you guys in the next video.